Testing and DevOps from Katina Cookie. Anybody read this book already? I don't see any hands. So highly recommended. It's on LeanPub, so you can easily find it. So it's not expensive. Now, continuous delivery, that's all about our ability to get a lot of different kinds of changes into production. That's how Jez Humble defines it: safely, quickly, and sustainably. So it might be a configuration change, it might be an upgrade to some framework we're using, or new features or bug fixes, whatever. Might be things that we're going to experiment with and feature flag or feature toggle and only turn on for a few users, or maybe A/B testing. So lots of things that we may deploy to production, and we want the ability to do this whenever we want to, whenever we have a good release candidate. And, you know, obviously benefits from automated regression tests, although it's not necessarily a requirement. And the idea here is that we always have a deployable release candidate. We may not choose to release it right now, but we could. And so here's an example pipeline of unit testing, static analysis, integration testing. And the steps outlined in blue here, those are manual steps. And I think that was something that I kind of became aware of in the last year, working with people like Ashley Hunsberger of and Abby Bangser of, you know what, even if we do something manually, it's still part of our delivery pipelining. So if we need to deploy to a test environment in order to test it, and that deploy happens to be done manually, still part of our pipeline. Things like exploratory testing, we're doing them manually, or security testing that we do manually, whatever, still part of the pipeline. So we really have to think, how does this fit into our pipeline? And it may be asynchronous. So it may be something that we take off and use feature toggles so that, well, we haven't finished our exploratory testing, we're not going to turn that feature on in production, but we are going to deploy that code to production. Does that make sense? Anybody have any questions so far? Just holler it out, because I can't really see hands very well. No. What's that? Oh, awesome. So we talked about the manual steps in the pipeline. And I know it's awkward for y'all to contribute, so I'm going to keep going on this because we're going to talk about it more later. So I mentioned Jez Humble, his book with David Farley that's my Bible of continuous delivery. And if you read that book, it's all about testing, really, which is super cool. So these are the principles of continuous delivery that he gives. And again, we're just talking here about kind of a really narrow slice of DevOps and continuous delivery. Just having a pipeline and automated test suites doesn't mean that you're doing DevOps or continuous delivery, but these are key success factors for DevOps and continuous delivery. Now, you may have heard the term continuous deployment, and it is like continuous delivery, except every time you commit a code change or any kind of change to the product, it's going to go, if the build passes, nothing bad happens in any of the test suites, it's going to go right out to production. And a lot of companies are doing this many times a day. And again, benefits heavily, I think I left out the word benefit, benefits heavily from automated testing, but it does not require it. So that's kind of weird to say, but it's true. So I think I have a slide for this. Yeah, I got it later on. And here's an example of it. So again, it looks just like continuous delivery, but because we're doing it automatically, we're not pressing a button or anything to deploy to production. Maybe we've taken some of these things, they're asynchronous. They're not part of the main pipeline. They still have to be done, but if we haven't done them yet, we're still going to deploy to production because it's all automatic. So any questions about continuous deployment? I don't see any hands. Okay. So Ashley Hunsberger has this great analogy. You know, I've said that these things benefit from test automation, but doesn't mean you have to have it. And it's just like, well, you know what? You could drive at night without your headlights. And if there's a full moon or you're driving in a big flat area with nothing in the way, that might be fine. But the headlights reduce your risk significantly. I said here the whole team approaches one headlight and automation regression tests are the other. Ashley feels that the automated regression tests are definitely one headlight and monitoring in production is the other. So that's another really important part of DevOps is monitoring in production and observability. How many people have heard of observability? Anybody? It's pretty new. So, huh? Oh, good. That's awesome. So, the observability is, looking at what's happening in production, instrumenting your code so that if something happens in production, you can dig into your log files and figure out what happened, but you don't necessarily have it in your monitoring or have an alert for it because it's not expected. So it's the ability to discover things that aren't expected and learn from things that you're not even monitoring. And my friend Abby Bangser, I was at European Testing Conference last week, and Abby Bangser is doing a lot of work in this area, and she works for Moo in the operations side of things. And she says that observability is the bridge to DevOps for testers, because a lot of the skills required for that are things that testers are already good at. So, for example, we tend to be really good at risk analysis of, what are all the bad things that could happen and what impact would it have if those things did happen in production? And we're really good. One of the talks I went to that I heard last week from Sarah Wells, who's head of kind of operations or DevOps for the Financial Times based in London. She said that chaos engineering, if you've heard of chaos engineering, she feels that's exploratory testing. So we may decide to say, what happens if we delete a table in the production database? That's chaos engineering. Is it a realistic thing to do, though? That's something that testers can help analyze. It's like, does it even make sense to do that test? Obviously, it's going to have a huge impact, but maybe there's no chance it'll ever happen. So why should we do it? So as testers, we can ask good questions, and that's what observability is about, asking questions. And so I'm really excited about that idea because I really see the value now that we have tools to deal with the big data that we get from all the logging that we do now and all the monitoring that we do. We've got really great tools for this. We've got machine learning to help us with it. And that's so valuable for our testing because understanding better what customers are doing really helps us know where's the value, where should we be focusing our testing. So a little side trip there, but that's just something I learned last week, so it's not my size. Oh, just to sum up these terms, we talk about deployment pipeline, from commit to deploy to production. We've got continuous integration, continuous delivery, where the business approves it and we deploy to production, and continuous deployment, which we skip the business approval and just go right on ahead. Does that make sense? Any questions? Okay. So one of the things I recommend you do with your own teams is try to get a group of team members together, developers, product people, operations, testers, and write your pipeline steps or stages on cards or big sticky notes. And you can do this on a virtual sticky note board if like real-time board, if you're distributed teams. And just try to arrange them. Like, what does our pipeline look like? And then talk about it. And I found this for me as a tester, it really helped me understand our pipeline for starters. And then we could start asking questions about it of, well, how can we shorten some of these feedback loops? Are there things we could be running in parallel we're not currently running in parallel? Are there manual steps that we're not even representing, but they have to be done? So let's talk about them. Are they something that we should try to automate eventually? I think it's nice even just to have it permanently up on your wall, to keep talking about it and keep changing it as you improve your pipeline. So a super valuable exercise, and when I do workshops about this, I have people do this just on a table with cards. So it can be a really powerful thing to do, and it's easy. It's pretty easy to do. It doesn't take long. You can do this in 30 minutes. So again, thinking about the things you could do to make it more effective, things you want to automate. So many of us are running cloud native applications now. What can we host on the cloud? How could we benefit from the cloud? And the things that it gives us. So for example, for testing, my company's product, Mabel, each one of your tests that you have automated runs in its own container in the cloud. And what that means is all of your tests run simultaneously. And that's a lot faster than running them sequentially. They're all parallelized. And so your UI test suite is as long as your longest UI test. Those are the kind of things the cloud gives, and running all the browsers at the same time. So those are the kind of benefits we can get from the cloud that we didn't have those things before. So it's really, really exciting. I feel like it gives us a whole new generation of tools to help us with testing and to free our time up more as testers to do the really serious exploratory testing and other testing activities that we can add value as human beings, whereas some of the repetitive things that can be automated, we can make those really quick and get that quick feedback by automating them. And what test do you feel like you need to be confident for continuous delivery? And again, this is something you can talk about when you visualize your pipeline. This is another really cool thing. You can download this from GitHub from Ashley Hunsberger. And I'm imagining that many of you have different automated test suites. You got maybe a unit test suite and maybe API tests, UI tests, security tests, whatever, performance, load tests. And this thing is a way to look at all the different test suites you're running in your pipeline and what you're trying to learn. So what do we want to learn from our unit tests? Who needs to know that information? How should they get their information? And so when we need to think about when we run our continuous integration and run those unit tests, we need to make sure an alert comes out to Slack to the person who checked in that change, or maybe we want to have something turn red on the board. My last team, everybody was pairing all the time, and we had these big monitors on the wall, but people weren't looking at them because they were heads down pairing on writing new code. And so our production delivery pipeline would fail and be red up on the monitor, but nobody would pay any attention to it, which is really frustrating. So we actually hooked it up to a police light so that when the build failed, a blue light would go on in the team area. And that really got people's attention. So thinking about who needs to know, how fast do they need to know, that's a police light is one good way to tell people. And then just other things about this. What is this dependent on? A lot of times we run tests that are dependent on something that's external to the part of the application we're working on. Is that something we can do a fake or a stub or a mock, but we don't actually need that system because we're not testing it, we're testing our system. So, thinking about constraints, data is a big thing. Do we have each test create its own data? Do we have canonical or fixture data that we use, that we refresh before every run of the test? How do we manage that? Maintainability. Do we do code reviews? Are we doing pair programming? Is our code understandable to everybody? So I just love this test. I love this canvas. It's just another great way to kind of guide your conversations about what you need to succeed with DevOps and continuous delivery. And again, with DevOps, we're talking about infrastructure as code. We need to also test that infrastructure. So all the ways we're, configuring containers and deploying in the cloud, we need to make sure that is reliable as well. So just quickly going through some of the Canvas discussion points, why do we do each step in our current pipeline? On my last team, I noticed that our actual deploy to production pipeline ran all the tests again, even though our release candidate was cut from master and only cut if master was green. So we've already run the tests. Do we need to run all these tests again that we just ran? Maybe we could get by with just some smoke tests. So those are the kind of questions to ask. And again, what we want to learn from each step, who can benefit, how they should be informed. I kind of already talked about all that. The API test suite, we could test for response codes, for example, or we could test for the JSON response that comes back. Is that good enough? Can that replace some of our UI testing, or do we need additional UI testing? What business functionality can we test at that level? Does the build install without error? There's no reason to try to test. We've deployed to a test environment, and if the build got errors when it was being installed, do we want to test that? I probably wouldn't. Dependencies, lots and lots of dependencies to talk about here. And again, here's where you need to possibly build relationships with other teams or other people. Constraints, do we have a manual step that probably would be easy to automate, or do we have automation? How many people have automated tests that are too slow and too flaky or too flaky? Raise your hands. Yeah, a whole bunch of you. What are our known workarounds? Constraints are good. They make us creative. They make us innovative. But we have to talk about them. When we're looking at, we're visualizing our pipeline, we want to look at what kicks off each step in your pipeline. And we talked already about parallelizing it. It's going to shorten those feedback loops. And then if a step fails, do you want to fail the next? Do you want to not even start the next step? Or do you want to keep running your test because you want that additional information? There's no right or wrong answer either way. It's whatever works best for your team. But you think about those triggers. And same with gates. It's like we have a known defect. We just want to get that feedback and stop our pipeline. And I mentioned flaky tests. I've worked on a lot of teams where it's like, oh, well, we just label the test flaky. Well, what that means is when it fails, we don't pay any attention to it. And 9 times out of 10, I found if you go look at those tests and say, how can we make this test not be flaky anymore? It's a real bug. It's just a bug that happens sporadically in only a certain set of conditions. Like maybe the test data has to be in a certain state, or some other test is running at the same time and impacts it. So either delete the tests that are flaky or fix them because they might really be a bug. And then we have new technology. So, I hate to keep plugging Mabel, but Mabel uses a lot of heuristics to where, for the UI tests, to where it's like, well, it's looking to interact with a particular element with a certain name, but there's no element on the page anymore with that name. Well, Mabel took in a lot of information about where that element was on the page and what things were around it, and it can often find the element even though the name changed, but it's still there, and it can find it and keep going. So we can take advantage of this new technology and machine learning and things like that to make our tests more reliable, and as well as really just good coding practices and good automation practices. Test data, I mentioned, using test doubles, using fakes for, it's not only at the unit test level we can do this, we can do this even at the UI level. If we don't need to test an external system, we can just fake out the response from that system. So lots of options for test data. And again, it's really tough sometimes to get production-like data. And this is where the testing and production comes in. None of our test environments are ever going to look exactly like production. So now that we have these really good tools to analyze the fire hose of information we can get from our log files in production, we can actually put things out in production, maybe only turn a feature on for a small percentage of users, and look to see, Are we getting error messages from it in the log files? We have the capability now. We have the tools to let us do this now. Now, I wouldn't do this, with anything life or death risk or something that could cost people a lot of money. But again, that's where testers come in. It's like, this is something we feel comfortable testing in production because it's not going to impact anybody in a horribly dramatic way. And because we have a really good, reliable continuous delivery process and we can deploy to production quickly, or we can revert changes quickly, it's safe to release it. If there's a problem, we can revert it, or we can get a hot fix out to production really quickly. We have those options available to us that we did not have even a few years ago. So it kind of expands our range, and that lets us focus our testing on the really high risk, high impact things. It's like we definitely do not want to put this in production till we're 99% sure about it. So again, this test suite canvas from Ashley, just use it to talk about things and look at the highest priority thing that would give you more confidence for continuous delivery. So DevOps, what we often hear, and I mean, I use that term myself, I'll say somebody's working in DevOps, but often people will have DevOps specialists that help the rest of the team learn the skills they need to participate in that and to do DevOps activities. But it's really a culture, and as you all mentioned earlier, it's a collaboration with everybody on the team. So we've talked already a lot about building relationships. So think about how you would do that. And, we're humans, and that makes us good at testing. And if you're trying to build relationships, just talk about the weather, put a dish of candy on your desk and invite people to come have some candy and talk to you. Do food. That's a great pattern. When I am really eager to share an idea, like say I learned something at a conference and I want to tell people about it, I'll say, hey, I'm going to do a 30-minute overview of example mapping because I just learned about it last week at European Testing Conference. And I'm going to provide really good artisanal cheese because I know my team loves cheese. And that'll help get people to the meeting and learn about something. And if you're sharing something useful, they'll be glad they came. And asking other people to share their knowledge. That's a great way to build relationships with other teams. So you might ask people who are developing your infrastructure as code, hey, come and talk to us about that, or come talk to us about our pipeline or our deploy process or our monitoring process. Pairing and mobbing. Do any of you in the room, do you do pair programming or mob programming right now, or pair testing or mob testing? Yeah, a few of you. That's awesome. In terms of pairing, I like strong style pairing the best, where there's a driver and a navigator. So if I have an idea, I ask you to take the keyboard and I tell you what to type, and I get to watch the screen and see what happens. So I get to have my focus on the screen. It's really great for exploratory testing. And then if the driver now has an idea, then I become the driver, and she does the observing as I type. And mob programming is just taking that up a notch to where we have more people involved and we rotate those roles with a really quick time box. So it's a way to kind of get a bunch of, 2 or more minds working on the same problem at the same time and focus on it together. You can really generate a ton of ideas. And especially like pairing with a designer or having a mob that has the product owner, the designer, the tester, the developers, whoever, the operations person, different people there, so that if you have a question, the person who can answer that question is right there in the room. You don't waste any time going to find somebody to answer a question. And there's some really good books. I really like the Mob Programming Guidebook on this to learn how to do strong style pairing and mobbing. Again, works really well for testing as well as programming. And lean manufacturing, we got a lot of these ideas from Toyota. And, we also know that empowerment and autonomy are great motivators. That's what we do. That's how we love our job, is because we're free to take action if we see a problem, and that's something that Toyota did on their assembly line as well. And that's again the benefit of the whole team approach. Anybody can see a problem. The tester might notice a problem with the production monitoring, or I mean, a lot of times I find it's the testers on the team who even notice that on the monitor that the build broke, or who notice that, oh, we're getting a lot of 500 errors in production since we did that release, since they're looking at New Relic or whatever is monitoring for us. So anybody can contribute, and it just has tons of different benefits. And so we learn from production use. I talked already about, I got ahead of myself. I talked about testing in production, big data, and all those kind of things. And I mentioned learning releases from our data garage. I think that's really a great way to look at minimum viable product. People don't really understand sometimes what that means. And it's also very hard to do less and do something really minimal. But if we think about it as a learning release, it's like, what's some small slice of a new feature that we think people would like that we can get out into production? Maybe we feature flag it, show it to certain users who want to be beta users, and get their feedback on it, and find out if we should keep going with that, or if we should say, well, that wasn't something that was valuable to them, or it's not the right approach, let's rethink it. So we need a lot of discipline, though, to be able to respond quickly to customer pain, respond to alerts, monitoring tools. And again, artificial intelligence and machine learning are helping us process just this fire hose of data. If we're instrumenting all of our code so that every event generates something in the log file, we need a way to look at that log file. We can't do it with our human eyes. We need something to help us process it and pull out the things we need. So we have a lot of query tools now that help us do that. Feature toggles, my last team really struggled with them. We try to feature toggle something, and either we would accidentally turn it on for everybody, or it would break the existing functionality. So learn how to do that. And there are a lot of terms. You can read about these in Katrina Klucke's book of dog fooding. I prefer the term drinking our own champagne. So with Mabel, we test our product Mabel, which is a test tool, with our own test tool, Mabel. So we have Mabel on Mabel tests. That's an example of dog fooding. Canary releases, putting something out, turning it on just for a few people. Those are all similar things. Canary release, stage rollout, dark launch. I feel like I'm going on too long because y'all want to get to questions. So these are some of the tests. These are some of the activities we need to fit in. And we do this again with a whole team approach. Anybody can do a testing task. We work together, and we can do it quicker when we work together. Okay, so I mentioned infrastructure as code. I didn't really go into it. Containers, these are all things I use these words, but these two books I highly recommend to get more into those topics. So again, work with your whole team. Get together, figure out what's our biggest obstacle to adopting DevOps practices, to building a DevOps culture, to having effective pipelines, to having reliable deploys to production. If we have a whole team commitment to do the best, to do a really great job of that, make our customers really happy, we've got the expertise on our team between all our different skill sets, all our different experience. But it's not going to happen overnight. So be happy with baby steps. Pick one problem to work on, make that problem a little bit better. I did a blog post recently on shifting left and shifting right. I'm not a big fan of those terms because software development isn't linear anymore. We're not doing waterfall anymore. We're having feature ideas and we're putting them out in production and getting feedback and learning from that and getting more feature ideas. So it's a continuous process. So I wanted to make some time for questions. What questions do you have? And this is my donkey Chester. Nobody was harmed in the production of this slide deck. He's just making sand angels.
Speak very loudly. Oh, good. Hello. My name is Teresa Potts, by the way.
Okay.
Just want to say hello. Um, so I know we kind of talked about DevOps and the roles kind of within that, but are we imagining these people on their own DevOps team, or are they actually part of a feature team and they're like just members within a feature team that get together and do DevOps and maybe a rotation or for a certain period of time, that kind of deal?
Yeah, it's a really great question, and I think a lot of people approach this the wrong way. Like I say, I think it's okay to have a DevOps team if your organization is just trying to start it. So get people who have done it before to help everybody learn how to do it. Like, okay, now developers have to learn how to configure pipelines, and now um, operations people have to learn how to code because now we're going to do all our infrastructure as code instead of doing weird little Unix commands on the command line. Um, and obviously, testers need to learn things as well, and people need to learn things from testers. So I think you may start out having some DevOps specialists or DevOps team, but everybody needs to be involved. My last team, the way we handled it was basically whoever was interested in it. So people who are interested in working, configuring pipelines, doing the cloud platform configuration, monitoring production. The people who are interested in that, anybody on the team could participate, including testers. And we had our own DevOps backlog of infrastructure-y things that we needed to do. And we met once a week to talk about that. And then we would work those stories into our regular, our sprints or our iterations, so that some of the people in the team were doing DevOps things rather than working on feature stories. And that worked really well. I think because they did it because they were interested, and because we met regularly, made sure people were learning how to do it, pairing up with somebody who already knows how to do something, so you learn how to do it too. Somebody has to be on call, so people need a lot of expertise to do that. And that was a good approach that worked well for us.
Another question I had is, when does something get too big for the DevOps team and actually has to go back to the feature team?
Hmm. Can you
Yeah.
give an example of that?
Um, you find maybe that there's something in production affecting users, and you start digging into it, and there's something that's kind of a bigger thing than just, hey, let's just fix this one line or two lines of code. This is actually more of a um, service wide thing that needs to be reapproached.
Oh, that's a good question. I think you have to take it case by case. I know a lot of the leaders in observability, like Charity Majors. She's Mipsy Tipsy on Twitter, so follow her if you want to learn about observability. Um, she's a proponent of whoever worked on developing a new feature should be on call when that feature goes to production and try to fix it themselves. But like you say, a lot of times just because something happened in a particular part in the code, it may not really be that code. It may be something else that's impacting it, something else that's behaving badly and impacting it. So yeah, I think those things do need to come to your team. And the way my last team handled it is that we'd have every day we'd have a pair of developers who were the kind of support pair. They were watching production and they dealt with production problems. And it was basically up to them. They would take that problem as far as they could. And if it couldn't be fixed and it was critical, then we would assign somebody to be, I can't remember the term that we use, but we would assign somebody to kind of take charge, be the incident commander, maybe that's what we call them. And then the incident commander would pull in the people that she or he thought would be able to help solve the problem and, do more analysis on it, find out what the problem really was, and then based on where it really was, then find the appropriate person who could fix it the fastest. So that was an approach that we used, and it worked really well. We had a playbook. So if there was an incident like that, we had a process for escalating it and making sure that we could get the whole team's attention and the whole team's involvement as much as we needed.
And I guess one last question. I guess, how do people approach when you have like a technical improvement where, like, as a tester, you can't necessarily have your usual hands-on involvement where like maybe some third party tool that you use is having weird um, some weird occasions with what you're doing. So like maybe like Redis cache is doing some really weird things and you can't really test that in a normal way or with a front end or even check the database or anything like that. It's just this weird infrastructure thing, but you have to be like, yeah, it's ready to go, but you can't really test it.
I mean, is it due to like an actual problem in the tool or a tool like Redis, or
Sort of.
just something that you don't really, the tool just doesn't handle it?
It's sometimes can be a bit of both once you dig in and find out kind of what's going on, but obviously it's really dev heavy of trying to understand what's happening and then even trying to fix it and verifying it's fixed. Like they have to heavily dev test it, but beyond that, is there really anything you can do to really feel comfortable? I mean, you can run automated tests, but like,
I guess if it's possible to keep it under a feature toggle, that could be one way to do it, and then just like turn it on for a few users and see how it goes. And if not, it's just, I would just, instrument the code as best as possible. My current team, they instrument absolutely every event in the system, so that if something does happen, they can pinpoint the cause really quickly. So for the things that they don't feel like they can test adequately, they're relying on that, which most of the time is okay. But for the really high impact things, we had an incident about a month ago that impacted all of our customers for about an hour and a half. Well, that's not okay. And so we're revisiting our process now to see, we're definitely like, we're consciously not testing enough. Not taking the time to test and thinking that we could handle it by monitoring in production and just reverting the change really fast if anything bad happens. Mm-hmm. That works a lot of the time, and it works well if it's not high risk. But if you're doing life critical type software or financial software or things like that, I would, or launching rockets. I might not want to take that approach. I know that's not a very good answer, but
no, I mean,
I think it's just a case where it really pays to have people in multiple roles and multiple skill sets brainstorming about it.
Okay. That's all my questions.
Good questions. Thank you. Mm-hmm. You probably know a lot more about this than I do.
Yeah, I don't think so. That's
anything else?
Hi, Lisa. My name's Clint Hoagland.
Clint.
Hi.
I know you on Twitter or something?
I think so. Yeah, we are Twitter buddies. So let's say that you want to move in the direction of continuous delivery, but the testers that are working with your developers are what you'll call, they didn't come from an engineering background. Mm-hmm. What are your suggestions, if any, for like technically onboarding those people into some of the more coding concepts?
Oh, that's a really good question too. I mean, I think part of it is to get them a grounding in the terminology, being able to speak a common language about it. So, I mean, I find a really effective way to do that is pairing. So if I can pair with somebody who's working on, I'll give an example of coding. If I can get familiar with the IDE that people are using, then when I pair with them, I'm going to have a lot better ability to communicate because I'll understand more what they're doing, or I can look at that code on my own because I have the IDE. Just kind of learning more of the infrastructure tools is really helpful. Personally as a tester, I want to learn how to do things like, how do you, we have BigQuery. How do I query and get the data that I want? Or, we've got some analytics tool. And so can I pair with somebody to learn how to use the analytics tool, or can somebody write up instructions? So sometimes it just helps to document that stuff, how to do it. And sometimes you really need more in-depth knowledge for pairing. And that's why I like pairing and mobbing. But also just making time to learn. So maybe there's a an online course they can take. Just giving them time to take that course and learn. On my last team, we had a lot of cases where one of the developers would just schedule an hour-long workshop on something like, well, here's our, we switched to a new continuous integration tool. So here's an overview of how to use it. And then here's some resources for investigating that further. So, they would do that for the whole team. And then, if I felt like I needed extra help as a tester, I would just go ask somebody to pair with me and give me that extra help. I don't know if that's a very satisfactory answer, but I think
that's helpful.
Time to learn and support to learn are really important, because I think a lot of times the testers sort of get overlooked. Nobody thinks about them needing to learn something, so they're busy trying to catch up with all the testing. So taking that pressure off of them and giving them time to learn is really important. No. But you're right too. Like we need a common language to communicate. And so if I'm not familiar with that tool and I don't even know what the words mean, I'm not going to get anywhere even if I pair with somebody.
I think that is a useful thing to think about, though, like the idea of using pairing intentionally as a educational experience, right? Like that, because I think that the testers that I work with are sort of reticent to say, I want to pair with the developer while they're programming because I don't know how to write code.
Right. Yeah. The good news is that, even if I don't know how to write the code, I can still write pseudocode. Like I can still say what I think the code should do. And I've been lucky to work with programmers who were supportive in that way. It's like, okay, just write it in pseudocode, and then I'll turn it into code. But even if you don't do that, you're going to ask questions. Just say, well, what does that mean? Or what exactly are you doing? Or what is this unit test doing? And it helps them too, because it helps your pair think about what they're doing as well.
All right, thank you.
That's all the questions that they have here. So
okay, let me just real quickly, and I can send these slides to you. I mentioned the continuous delivery book, Practical Guide to Testing. Another book I highly recommend is Accelerate, which is about the DevOps. Now I can't think of what it's called. State of DevOps Survey. That is a really, really valuable book, and you would learn a lot from it. I listened to the audio version. It was awesome. Nicole reads it herself. And then Charity Major's blog, and I mentioned Ashley's Test Suite Canvas. And then I've got, if you're interested in our books, why is that so furry? Little discount code if anybody's interested in it. And then I guess that's it. I thought I had a contact slide and I don't have it, but you can contact me, lisa@mabel.com or lisa@lisacrispin.com, and I'm Lisa Crispin on Twitter. And I love hearing from people. I'd love to hear what you're doing. If you go back and try any of this stuff with your own team, I would love to hear what you try. And it sounds like some of you all have a lot of experience, and I would love to learn from you too. So if you know of any good blogs I should read, for example, I would love to hear them. And thanks for your patience with me as I started off thinking I was doing something else.
Thank you for presenting. Really appreciate it. So let's give her a hand.
And the technology, I'm going to stop sharing. The technology worked great.
Yep.
Let's see. Stop share. Yay! Look, I can all see you better. Yeah, I love that you have a lunchtime group. It looks like y'all have a great time and a lot of great topics, I bet. So very cool. Thank you very much.
Yes, thank you. And I'll work on getting the slides from you later on. And then if anybody has any questions, you can get them to me, or you can post them on the Meetup site in the discussion area below.
Oh, that's right, the Meetup site too. Yeah.
So then we can get answers to those. So, all right. Thank you, everybody.